Could that actually happen? Could the rocket launcher from TF2 actually splatter you into a bunch of parts? Well, according to the TF2 wiki, Soldier's rocket launcher is a heavily stylized RPG-7. It's a rather old Russian RPG design meant for anti-tank warfare. So presumably it's got enough firepower to turn Blue Team to a horrific purple paste. Yep, Soldier's the communist, not heavy.
You're a disgrace to the uniform.
The RPG-7 weighs about 14 pounds and it can fire various kinds of ammunition. If you play the game and look at the rocket design, it appears to be an RPG too. These were designed to penetrate up to 7.2 inches of tank armor using the Monroe effect. Pretty much this thing leaves a large hollow dome within the target in order to force a shockwave. It's catastrophic, at least to a tank. Our next question. What was tank armor looking like back when the RPG-7 was created in the early 1960s, right? Because 7.2 inches of tank armor back then might not mean as much as 7.2 inches of tank armor right now. So let's be generous and select the heavy USSR tank, the IS-3M. Fun fact, this tank was invented about 20 years before the RPG-7, but was still relevant when the RPG-7 came around, and is still relevant now. Unfortunately, the footage you're seeing is probably some unrelated tanks, but hey, I think the idea is illustrative. It's got 4.3 inches of hull, homogeneous steel armored plates. So Soldier's rocket, assuming it is actually the RPG-7 or something equivalent, it could easily penetrate the hull with its 1.8 kilograms of high explosive anti-tank, aka heat explosives. Now, the actual explosive in it is a composition A3 type 2, and according to this chemical and physical characteristics paper I found, the composite is 91% RDX and about 9% polyethylene. Now we're gonna just ignore the polyethylene completely because I'm lazy. So what is RDX? Well, it's an explosive alternative to TNT, and it's got an explosive energy per unit weight that is 1.5 times that of TNT. So if we do the math, 1.8 kilograms times 0.91 times 1.5 equals 2.457 effective kilograms of TNT. Remember that this is us being conservative. The warhead is designed to concentrate this explosive power using vacuum pressure, and we will consider that in a little bit. So 1 gram of TNT is about 4,000 joules of energy in an explosion. Soldier's rocket is putting out 9,828,000 joules of energy, which is also 9,828 Newton meters. That's the literal definition of a joule. But we have one more question to answer. That is, how much force can the human body take? Well, this question is kind of loaded. What part of the body, what force applied, on what time interval, and at what distance? Let's just say the femur at point blank range. Why? The femur is the strongest bone in the body. If an explosion can tear through the femur, we can be pretty confident that it'll tear through any other structure. So if we measure the force that the femur can withstand vertically, it's about 205 megapascals, which is quite decent. If we measure it horizontally, then it's only 131 megapascals, which is to be expected because the femur is designed mostly for compressive strength, not tensile strength. Likely a soldier will not be rocket diving onto our heads directly, so let's take the horizontal value. Our yield of 9,828 Newton meters in our rocket was squished into a diameter of 40 millimeters. Let's assume the surface of the impact cone is a circle. That means we are looking at an area of 0.00125 meters to hold 9,828 newtons of force. If we standardize this to a square meter, it would be about 7.8 billion Newton meters squared, which is about 7,820 megapascals. This is much greater than the maximum force the femur can withstand. So is this footage possible? Could the rocket launcher from TF2 make you go splat? The answer is yes, very easily.